Welcome back to Step Electrical. Here, once again, we are here to discuss a numerical related to Ohm's law. Here, an aluminium wire of length 7.5 meter is connected in parallel with a copper wire of length 6 meter. Both are connected in parallel. Now, when a current of 5 ampere is passed through the parallel combination, it is found that the current in aluminium wire is 3 ampere. The diameter of aluminium wire is 1 mm, and now we have to determine the diameter of copper wire. Whereas the resistivity of copper is 0.017 micro ohm meter and that of aluminium is 0.028 micro ohm meter. So according to this numerical, the figure is, this is aluminium conductor and this one is copper wire. This is aluminium and this is copper. Now as the 5 ampere current passes and 3 ampere passes through aluminium wire, then the remaining current, that is 2 ampere, will pass through this copper wire. So this is just a simple common sense application of common sense. Now how to tackle this problem? I have written some steps, and the steps are, we know for any parallel combination voltage is always same. So V1 is the voltage across this aluminium and V2 is the voltage across this copper wire. So V1 equals V2. This is our condition. On the basis of this condition, we will solve this numerical very easily. And we know from Ohm's law that voltage is equal to the product of resistance and current. So for V1 it is I1 into R1 and for V2 it is I2 into R2. And again we know R is rho L by A, so for R1 it is rho 1 L1 by A1 and for R2 it is rho 2 L2 by A2. And here area is given by pi d square by 4. So these are the steps which we will follow to solve this numerical, and on the basis of this step we will easily find out the diameter of the copper wire. So let's solve. Here the given is, first of all we will write all the givens. For aluminium wire I have supposed a subscript 1, and for copper I have assumed subscript 2. So for aluminium, length is L1 is 7.5 meter, diameter D1 is 1 mm, and we have to change it into SI unit, so it is 1 into 10 to the power minus 3 meter. A1 is pi D1 square by 4, that is 7.854 into 10 to the power minus 7 meter square. So area, unit of area is meter square. Now I1 is 3 ampere and rho 1 that is given, which is 0.028 micro ohm meter. On converting it into SI unit, it is 0.028 into 10 to the power minus 6 ohm meter. Now the voltage drop across aluminium wire is V1 is equal to 0.8022 volt. We have find out using this relation, I1 into rho 1 L1 by A1. So you can easily find out. Okay, now for copper, L2 is 6 meter, diameter is unknown, we have to find out, and for that A1 is also unknown, A2 is also unknown, that is A2 is pi D2 square by 4, and we have to find out. So the given are, the next given is I2, that is 2 ampere. From this figure we have find out, and rho 2 is given here 0.017 micro ohm. On converting it into SI unit, 0.017 into 10 to the power minus 6 ohm meter. Okay, the voltage drop across the copper wire is V2, is given by this relation V2, I2 into rho 2 L2 by A2. Okay, now the main condition for this question is V1 equals V2, that the potential drop across any conductors connected in parallel are same. So V1 is V2, V1 equals V2. Now V1 is known, that is 0.8022, and V2 is 2.04 into 10 to the power minus 7 whole divided by A2. Okay, so A2 is 2.54 into 10 to the power minus 7. This is a simple calculation, so we have find out A2. Now using this expression we can find out D, that is 4 square root of 4a divided by pi. So here a2 into 4 divided by pi whole to the power 0.5. We know the square root is 1 by 2. Square root is anything to the power 1 by 2, that is 0.5. So on using calculator we can find out that d2 is 0.569 into 10 to the power minus 3 meter. So this is all about the problem. The first thing that we have to keep in mind that these are the simple steps, that voltage is constant. For voltage constant, then using Ohm's law, I1 into R1, and using the formula of R, that is rho L by A, and using the expression relation of A and D, that is A equals pi d square by 4, we can easily find this numerical. You don't have to worry too much. Okay, this much for this problem. Hope see you in next video. Thank you for your patience and attention.